Today I have chosen very important topic as it is used in solving complex problems. Doesn't matter how much noisy our data is, backpropagation playing vital role to find out an unrecognized pattern. So it is highly recommendable algorithm proven in medical field. As a brain tumor is the biggest application of the backpropagation, we can say, although it take long time for training and less interpretable. Now let's talk a little bit about how backpropagation helps in finding out tumors. So the method of neural network is used to identify brain images. A statistical feature extracted from GCLM and angles are used as input data, whereas normal and tumors brain images are used as target data. And for training, they are having bulk of tumored images already present in our data set. Alright, so let's start understanding first what is in detail. So basically, what is backpropagation we must have to know first. So a backpropagation is a deep learning algorithm used in machine learning to train neural network of a model in supervised learning with backpropaganda. In general, it's utilized to train gradient descent of error in simple or complex algorithm in deep learning to find the errors more accurately than others. As we are seeing in the figure, there's an input, hidden layer, and output and reverse direction arrow, right? How does forward pass work? In forward pass, initially the input fed into the input layer. Since the input and the raw data, they can be used for training our neural network, right? The input and their corresponding weights are passed to the hidden layers in neural network. For instance, consider illustration figure. There are two hidden layers and output of H1 can be used input of the H2, right? Before applying activation function, the bias is added. So the weighted sum of the inputs, the activation function applied in the hidden layer to each of its neurons. One such activation commonly used is ReLU can also be used, which is responsible for returning the positive input, otherwise returns 0. Alright, so by doing this, so it introduces the nonlinearity to our model, okay, which enable the network to learn complex relationship inside data. With the help of heat map or visualization techniques, we can also visualize it. And finally, the weighted outputs from the last hidden layer were fed into output to complete to find the prediction. And this layer can also use the activation function softmax, which is responsible for converting the weighted output into probabilities for each class. Alright, or in backward, what we need to do as we are getting errors, so we'll go backward to sort out the error, which helps the network to improve its performance via learning rate and adjusting the performance of the weights and bias. So we have to go backward, use the prior weights and bias and update there, and this process will be repeated until we achieve our target. So for that reason, we will use the MSE, that is mean square error, which calculate the difference between the predicted and desired output. Alright, so MSE is equal to y minus y hat whole square. That is our loss function, we can say mean square error, right? So we have to reduce the loss as an error.